Okay, Bismillah ar-Rahman ar-Rahim. This is Shadi Ubaid, and I'm talking today about enhanced computer-aided diagnosis system for automated detection and classification of MRI brain tumors images. Title of the research will be presented first, then introduction and background information, followed by problem statement, goal of the research, LR or literature review will be presented later. Methodology, database, feature extraction, classification, performance assessment, and timetable, work plan, results, discussion, future work will be presented after that. The title is Enhanced Computer-Aided Diagnosis System for Automated Detection and Classification of MRI Brain Tumor Images. Of course, we have CAD. CAD is an abbreviation for Computer-Aided Diagnosis, and we have MRI, which is a medical imaging technique. Brain tumor is an abnormal growth of brain cells in humans being hit. So it's very important to do an early diagnosis system. So once you have an early diagnosis point, it will be better for treatment process. And this tumor has different shapes, size, types. And since we have primary, secondary tumors, so those shapes and sizes, since they are different, so we have to try to diagnose them as much as we can in early cases, earlier than manual detection happens, so we can treatment or do treatment well. Brain tumor and other nervous systems cancer is a leading death, and it's a 10th leading death cause at United States. So those numbers, like around 18,280 adults deaths estimated to be happened in 2022. This is very important number to be considered in mind while we are talking about the classification. Since we have many types, as we can see here in the image, so we have many types to be classified and to be detected earlier. You can see here, you can see the red one, which could be considered as a brain tumor. Meningioma is our main focus here in the classification and detection points. We can see that meningioma symptoms may include headaches, seeing double things, maybe blurred vision, arms or legs weakness. So many symptoms which can be others, the same symptoms for other problems in the body. So we have to classify and detect those. As I said, there are many diagnosis ways: MRI, CT, simple physical exam, family history, but we are talking about MRI brain tumor images. So we have to make an early diagnosis as much as possible. Manual detection has some problems like inaccuracy, like late detection. So the need for a special technique to help in early diagnosis of brain tumor would be very beneficial and helpful for the whole community. And CAD system is very good one, and MRI is a chosen one. So we will try to reach our goal of the research, which is CAD software system proposed for detection and classification of brain tumor. This will be done using MATLAB. Firstly, we have to have a data set, then cutting of ROI. ROI stands for region of interest. And some assessment, we will talk about performance assessments. It's an iterative process, so it's not a simple process to do that system. So it's an iterative one, many times to try it. We have many works done at this area. So at the end of suggested research, a proposed CAD system or software is established to help the doctor detecting and classifying given brain tumors. So we will focus on meningioma type of of this brain tumor. However, it could be generalized. Many works has been done. We'll take two examples of it. For example, this work done at 2016, for example. This work has a data set of 688, around 700 images, are MRI, and they are using SVM. SVM stands for support vector machine, and ANN, which is artificial neural network, available at MATLAB also. Accuracy results could be good, which were reached to more than 90%. So this is a good work done here. Moving on to new works, for example, let's take this one taken at 2020. It has a small data set with around 233 MRI brain images. It uses cascade functions and then an wavelet transform, which is DWT, and CNN, which stands for convolutional neural networks, and it has around 90% or more than 9%. It's around 99%, which is very good work. So from those previous works, since there is no time, I didn't mention all of them, but from those previous works, we can conclude the following. To do such a system, we have to take a data set, then we will do something which we call feature extraction to extract features from given images, then classification, then after that we have to do a performance assessment. So what we have to do first is database, feature extraction, classification, and performance assessment. Database should be divided as around 70 to 80. We divided at 70% of total normal images, which will be taken for training the system, and testing the system will be done on 30%. These are an example. We from Kaggle.com, we took around 230 image of brain. So 105 was were normal ones, with around 73 images for learning and 32 for testing. As I mentioned, 70% by 30%. The same case was for abnormal ones with 1 to 4 abnormal images, 70% representing 87 images for learning and 37 images for testing goals. Feature extractions, there are many features to be extracted. We extracted around 106 feature. The main tool was the DWT. There is a features called or features which have a significant value, has called p-value. So this p-value could be detected the important feature extraction. 30 to 50 features in iterative process. It's suggested to be that number of features. However, we have reached 106 features. Classification, many classifiers has been used, as mentioned, as seen here, like SVM, kernel function, SVM is support vector machine, KNN, which is nearest neighbor, or K voting nearest neighbor. So to assess the performance, we used performance assessments, which are sensitivity, specificity, positive predictive value, negative predictive value, and accuracy. The accuracy is the main one. So through iterative process, we have reached the good results. This is a timetable done, as well as work plan. As I mentioned, firstly we have to do the data set, get the data set, then followed by getting a region of interest through MATLAB, then feature extraction, followed by classification. And that way we have to do it many times with many classifiers and many feature extraction techniques to reach the best result. However, the best results have been reached with SVM, KNN, and CNN. SVM support vector machine, KNN is nearest neighbor, key voting nearest neighbor, and CNN is convolutional neural network. And for the feature extraction, DWT has been used. The accuracy result is 82% with SVM, 77% with KNN, and 91 with CNN classifiers. So this is a p-value, as I mentioned. All features above the 0.05 has been taken, which representing around 106 features. As a discussion, simple discussion, and this is of course the sample of results has been taken for one classifiers. As I mentioned, all these classifiers has been tried. This is a simple comparison as a discussion point for simple comparison with the previous works done in that area in numbers, of course. Some of them have reached numbers more than us. However, the data set, the technique used is controlling this point. For the future, it's better to improve such accuracy result by adding more features and trying to implement different transform techniques. We use DWT, so if searching done on other techniques, it might be useful. Additionally, having some technique for other types of tumors, especially for famous one like breast cancer, is recommended also. This is just for brain tumor, and meningioma especially, and could be generalized for other brain tumors. Okay, that's it. Many thanks, and these are used references. Thanks, and see you later, inshallah.